We'll talk about on the interval from 0 to 2 pi, which is one time around the circle, and then we'll also talk about what if they wanted all of them, so that when you look in the back of the book, you'll know what all those answers mean. All right, so we're going to do letter A here. Once you've done a few of these, I think it gets easier. You just got to struggle with it. But this one, I can look at it and go, well, that's cosine of x, sine of x minus 3, cosine of x equals 0, because I can factor out the cosine. And you'll be able to do that too. This will be an easy one once you try a few of these. So we can factor out a cosine of x, and there's a very specific reason why I picked this one to show. Not necessarily for the factoring. But now we use the zero product property. In order for this to be 0, one or both have to be 0. So cosine of x has to be 0. X equals the inverse cosine of 0. In other words, take the inverse cosine of both sides. This asks the question, what angle has a cosine that is 0? So on one trip around the circle, that'd be pi over 2 and 3 pi over 2. But what if it said find all solutions of each equation, and then it didn't have that piece right there? What if it didn't include that? Then there's literally an infinite amount of answers, but how are we going to represent that? Let's take a look at the unit circle real quick. This is pi over 2 up here, which is one of the answers. And if you keep going pi radians around the circle, or half a circle, you get another one. You get another one by going pi radians, or half a circle. Then, if you go half a circle again, you get another one. And then another one, and then another one, and another one. And you can get the infinite amount just by going pi radians around the circle. You need to go? All right, see ya. So what if we did this? What if we said pi over 2 plus multiples of pi? Any multiple of pi, you're going to get another answer, guaranteed. That's all of them. And then you have this funny little statement that says n is an element of z's. In other words, n is an element of the integers. So in other words, n can't be a fraction. That's not going to work, because then you're going to land on a different spot on the circle. As long as it's an integer, you're going to be fine. So these answers right here are just from 0 to 2 pi. This would be the answer if it didn't say 0 to 2 pi, if it said all of them. All right, but we didn't take care of the other factor yet. This is really why I picked this problem right here to show. Sine of x minus 3 equals 0. Sine of x equals 3. And then that would be inverse sine of 3. What's the problem with that? Or what's the answer? Nate, what's the problem with that? Why not? Sine's got to be less than 1. Sine can't be bigger than 1. So this doesn't yield any extra answers. There's no more answers. Now we have answers. Pi over 2, 3 pi over 2, we just don't have any more. So that's why I picked that one. I don't want this to be a trick question. And you give me an answer, I go, ha ha, gotcha. I don't want to do that. I want you to go, sine of x can't be 3. Can't be bigger than 1. And then move on to the next problem. All right, so cosine squared x. Whoops, I don't want the parentheses that close. This one is factoring. We got to use factoring here. So we have cosine squared x here. And then how about plus 2 and minus 1? One of them has to be plus 2, the other minus 1. It's the factors of negative 2 that add to positive 1. So now we use the zero product property again. So cosine squared x equals 1. And now look at this. I am introducing the square root into the problem. When you introduce the square root into the problem, you need plus or minus. So plus or minus 1. And now we need, if we go back to the original instructions, don't worry about all of them, but just from 0 to 2 pi, then x is the inverse cosine of plus or minus 1. So x is 0 and pi. So 1 at 0, negative 1 at pi. I don't want this to be a trick question either. Cosine squared x equals negative 2. Cosine of x is plus or minus Square root of -2. If you're taking the square root of a negative, we don't deal in imaginary answers on this, so we are done with this problem. I think in the homework, if the student I was helping did it correctly, you'll have to take the square root of -3. Stop. You're done. Move on. There's no answer for that. It's imaginary. I don't want that to be a trick question. All right, this one. 4 sine squared equals 3. Sine squared x equals 3/4. So sine of x is equal to plus or minus square root of 3 over 2. And hopefully we recognize that as one of our unit circle values that we know. We have x is equal to inverse sine of plus or minus square root of 3 over 2. Now we have to take care of the plus and the minus. So we want to know where sine is square root of 3 over 2. And that's at the pi over 3's. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now let's go back to the instructions. I want to see, didn't have instructions. Good. I'm glad there was no specific instructions, at least for this, or that I typed on here. All right, here we go. So what if it said 0 to 2 pi, and then what if it said all? Let's look at the two different situations. 0 to 2 pi. Well, I just got to list them all. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. There's no way around it. You just list all 4 of them. What about all? I don't actually need 4 answers to answer all, because here's how we're going to do it. And the book doesn't do it like this, which kind of irritates me a little bit. They do write all 4 answers, and I'll tell you what they write here in a second. But here's how we can do it. We can start with pi over 3, and then go half a circle. Just go half a circle. Pi. Go half a circle. Go half a circle. Go half a circle. A multiple of pi will get you another answer. So how about x equals pi over 3 plus pi n? There's 2 of them. There's 2 of the 4 places where you have an answer. Just one happens to be positive, and the other one happens to be negative, and maybe that's what the book would have a problem with. They're like, well, one's positive and one's negative. And I would come back and say, well, so what? Well, thank you. That's my phone. I got turned down. But how about the other 2? Start at 2 pi over 3, and then you get the other 2, as long as n is an integer. As long as n's an integer, then we're fine. So, but the book would list all 4 of them, and then here's what the book does. You would see pi over 3 plus 2 pi n, which means get that one and then go all the way around, and you'll get another one. Go all the way around, and you get another one. Well, I don't think it's necessary. And then they write all 4 of them out. Just do it in 2 statements, no problem. Yeah.
So do you write the 2 statements as your answer?
So if it said find all and it doesn't say 0 to 2 pi, that's what I'll be looking for right there. No, don't worry about that. Yeah, don't worry about that. I imagine a college professor would say absolutely yes, but I'm fine. As long as we all understand that n's an integer, I'm good with it. Okay?
Something like this, there are no directions, you just assume all.
Yes. But I won't do that to you. If it's a quiz or a test, it'll be on there. Okay. Awesome. Good talk. All right. Find all solutions on the interval 0 to 2 pi of this right here. I picked this one to show an example of having sines and cosines in the same problem. I'd rather not have that. So why don't we turn this into 1 minus sine squared x minus sine x minus 1 equals 0. By the way, I will be showing you your quizzes, and I should probably do this on the board since I'm recording this. 1 minus sine is not cosine. Nobody ever said that. Not one time would I ever say that. They have to be squared in order for this to happen. It's got to be a Pythagorean identity. So cosine squared is 1 minus sine squared. You can't make up your own rules and call it good. Just can't do that. All right, anyway, I wanted to mention that while I was thinking of it. So we distribute the 2 2 minus 1 is 1, so we collect like terms. And normally, we try not to have the squared term be negative. And so you could add everything to the other side if you wanted to, or just change all the signs. That's another technique. It's like multiplying both sides by -1. Now, you could still factor this if the squared term was negative, but I think we're just used to it being positive, and we can always get it to be positive. So we have 2 sine of x, and then we have, how about a +1 there and a -1 there, because I need that 2 to be positive to get the +1 sine. And now we, now you have, it's like you have 2 problems left. So 2 sine of x equals 1, sine of x equals 1/2. Sine is 1/2 at pi over 6 and 5 pi over 6. Not the 7 and not the 11, because it's only positive. Now, the only time you'll have plus or minus is when you square root. Nowhere did I square root. I didn't square root there at all. So it's not plus or minus. It's just going to be the positive. And then over here we have sine of x equals -1. X equals inverse sine of -1. Sometimes I don't write the inverse part. I'm okay if you don't. And then that's going to be 3 pi over 2. So there's 3 answers on 0 to 2 pi. Oh, but let's talk really quickly. I know I said I wasn't going to do it, but I can't help myself. What if we have pi over 6, 5 pi over 6, and it said find all of them, so make that statement with n pi. Well, you can't do it with n pi. How are you going to do this in one statement? Pi over 6, this would be another 4 pi over 6, and then all the way over here would be like 9 pi over 6. So you can't do it in one statement. You'd have to do pi over 6 plus 2 pi n, because that'd go from here and then just go all the way around, then just go all the way around. And then the other one would have to be, it's 5 pi over 6 plus 2 pi over n, or times n. So on that one, you can't, they're not an even separation. So you can't do it in one statement. You'd have to do it in 2. All right, the last one. And on the last one, I go back to the fact that all this stuff has to be squared in order to make the replacements, in order to use that Pythagorean identity. They have to be squared. You can't make up your own rules. So with that being said, we're going to try to make these squared. Now, if you have cosecant and cotangent on the same side, it becomes a real mess. But if you get one of those to the other side, much more manageable. 1 plus cotangent x. And this whole purpose is to either get rid of cosecant or get rid of cotangent. And the only way I can do that is if they're squared. All right, so let's square both sides. Square both sides. Cosecant squared x equals 1 plus 2 cotangent x plus cotangent squared x. Remember, there's going to be a middle term in there because we're really foiling. You can't, there's no distributive properties of exponents. Can't do that. You got to FOIL it out. Now I can turn cosecant squared into 1 plus cotangent squared x. 1 plus cotangent squared is cosecant squared. 1 plus tangent squared is secant squared. It makes your life a lot easier if you try to memorize those, really. Then you can do this homework a lot quicker. All right, so 1 plus 2 cotangent x plus cotangent squared. Look what happens on this one. 1s are gone, right? -1 from both sides. And the cotangents are gone. Awesome. I love it. But we have to know how to finish it, of course. So cotangent of x is equal to 0. Now I want to know where on the unit circle is cotangent 0. Now, if you have to draw a unit circle to do that, so be it. Whatever you have to do to get the job done. So here, and these are the ones that we need, the ones where a 0 appears in the points. And so there's the 4 possibilities. But cotangent is cosine over sine, which is x over y. X over y. Here are your zeros. X over y on these two will give you the undefined, because that puts 0 in the denominator. So the two answers for this one on one trip around the circle is pi over 2, 3 pi over 2. That's where cotangent is 0. 0 and pi is where they're undefined. I love these. I enjoy this section. I think it's pretty straightforward, very algorithmic. Here's step 1, here's step 2, here's step 3. Sometimes it's tough to pick out what step 1 is, and that's where practice comes in. You just got to practice these. All right, your assignment is 5-3, number 1 through 29, odd.